Hello everyone, welcome to your last lesson of the school year. I can't believe we made it. But we're going to have a quick lesson today over pyramids, cones, and spheres, and we're going to keep talking about the volume. So take what you learned last time and pause your video and see what you can do for this bell work problem. So hopefully you're able to identify the different dimensions that we need to label on our figures. So for this first part, it says Mr. McFarland has machinery on his farm. It allows him to bale two different kinds of hay. He can do a round bale or a square bale. The round method creates a cylinder with a diameter of 6 feet. Okay, so if we were to label our dimensions here, our diameter would be 6 feet, which makes our radius 3 feet. Okay, and then it says it has a height of 5 feet. So that means that the total height of the cylinder would be 5. And it says the square method creates a square prism, which we have over here, which is a cube, and it has a height of 3 feet. That's the height, that's how tall it is. And then base sides of 1.5. So 1.5, 1.5. Then it says for part A, what is the volume of the round bale? Well, remember, volume is area of the base times the height. So the area of our base for our round bale would be the area of a circle, which is pi times radius squared. So this would be pi times our radius of 3 feet squared, which would be 9 pi. We're going to go ahead and leave it in pi so we don't round in the middle of our problem. Our height of the whole bale is 5 feet. So remember, this would be square feet, and then the height would be 5 feet. So we're going to take these two values here, and we're then going to do volume equals 9 pi square feet times 5 feet. So your answer would be 45 pi cubic feet, or if you rounded that to the nearest tenth, you get 141.4 cubic feet. So that's the volume of our round bale. Now, if we keep looking, we can do the same thing for our other bale. For part B, it says, what is the volume of the square bale? Well, remember, volume is still area of the base times the height. So the area of our base then would be this base times this height, area of a square. So this would be 1.5 times 1.5, or 1.5 squared. And then if you look at the height of your shape, you can then account that for 3 feet. So our height would be 3 feet. And some of you are also ready to just do 1.5 times 1.5 times 3 for the whole volume. That's fine too. Either way, you get 6.75 cubic feet. So then finally for part C, it says approximately, how many square bales contain the same amount of hay as one round bale? Well, clearly our round bale is much larger than our square bale. So if we want to figure out how much would be equivalent, we're going to take for part C, we would take, I'm going to use this 45 pi because it's more exact, and I'm going to divide it by this 6.75, and that'll give us the amount of square bales in our round bale, and you get approximately 21 square bales is equivalent to one round bale. Alright, so hopefully you were able to work through that. If you weren't, at least identify where you get stuck, and then hopefully you won't continue to make that same mistake. Alright, so let's go on with what we're going to talk about today. We're going to talk about pyramids and cones. Most of you guys can put this together. Pyramid, you guys have like ancient Egyptians with their pyramids, all kinds of stuff. But you need to know that these shapes have one base. And we still use the capital B for area of the base. So for this type of pyramid, you could have a triangular base, square base, rectangular. You could have a hexagonal pyramid with a hexagon as your base, all kinds of shapes. Your cone, your base is always going to be a circle, and we still know the radius and the diameter relationship there. So if you look at this, big B is still area of the base. This H is still height of the whole shape. And then this time, we're actually, because it's not a full, because your shape comes to a point, we're actually going to have to cut this volume into thirds. So this 1/3, remember, is the same thing as dividing by 3. So if you look here, and this is a really cool video if you guys have time to watch. I didn't want to put it in this lesson and extend it any longer, but if you want to type this in, it's a really cool video that shows you why the 1/3 is there and how it works. Here's kind of a little drawing to illustrate, but basically your cone is 1/3 of a cylinder, and your pyramid is 1/3 of a prism. So that's where the 1/3 comes from, or you just take the total volume and divide it by 3. Okay, so let's practice a couple. Make sure you guys are copying these down as your examples. Our process is still area of the base, and then we identify the height, and then this time we're going to do area of the base times the height, and then divide it by 3 again, because that's the same as 1/3 times area of the base times the height. Some of you like to put the 1/3 in as a fraction, which is fine. I just like to divide by 3 at the end. So this time, what's the area of our base? Well, our base is a triangle, and remember the area of that triangle is going to be 1/2 little b times little h, which is base and height. And remember, that base must be perpendicular to the height. So the hardest part with these problems is identifying which numbers you're going to use. If we look at the base of our shape here, this whole thing, we have this 18.9 pointing to this side, we have the 11 pointing to the left side, and then the 15 pointing to the right side. But we need to pick the two that are perpendicular. So we're going to take this 11 and 15 because they have this right angle in between them. So the area of our base would be 1/2 times 11 times 15, and if we do 11 times 15 and cut that in half, we're going to get 82.5. And this would be square centimeters. That's a nice number, so I didn't round that. Then it says, what is the height? Well, the height would be how tall our whole pyramid is. So some people might think this is the height. This is actually called the slant height. We actually want the height, and it's going to be perpendicular to the base. And if I erase this here, you should be able to see that perpendicular mark. So this right here is showing that this height, or this dotted line, is actually perpendicular to this whole base down here. So this is going to be the height of our whole pyramid. So for our volume, then we're going to do this 82.5 square centimeters times the height of 18 centimeters, all divided by 3. We're just going to work on rounding to the nearest tenth today. So if you stick that in your calculator, you get 495 cubic centimeters. So make sure you understand the difference between the height of the base, the height of the 3D shape, and then the slant height. And we'll talk about your slant height here in a second. Okay, another example. This one's worthwhile to write down also. So same process. We have a pyramid, so we're going to use that volume equals area of the base times the height, all divided by 3. So our base now is not a triangle, it's a square or rectangle, but in this case we know it's a square because these 3 and 3 are both the same dimension. So the area of our base would just be base times height, or 3 times 3, which would be 9 square inches. The height of our pyramid, so here's where we get a little confusing. The height of the pyramid is this. We need to know what this is because this is perpendicular to the base. They've given you this 11. This is called the slant height. So basically it's how tall that slanted side is from the base of your pyramid to the very top of your pyramid. but we don't want that. We need the actual height. So we need this value in here. But what you will notice, if I draw a little line here, I can make a right triangle. And my right triangle has 11 as the hypotenuse. The height we don't know. And then this base would be 1.5 because it would be half of this 3-inch base on the whole pyramid. So to find my height, I can go ahead and use Pythagorean theorem. I can say h squared plus 1.5 squared equals 11 squared. So h squared equals 2.25. I'm sorry, I don't want to subtract yet. I'll show you all these steps here. So we would have h squared plus 2.25 equals 121. I'm going to subtract my 2.25, so I'll have h squared equals 118.75, and then h would equal the square root of this. Now, this is not a nice number, so I'm going to leave this as a radical. So my height is the square root of 118.75. So then for my volume, I'm going to use that radical because I don't want to round in the middle of my problem. So my volume would be area of the base, which is 9 square inches, times the height, which is 118.75, and in fact the radical of that, or the square root of that, and then I'm going to divide that whole thing by 3. So go ahead and put that into your calculator, see what you get. I believe you should get 32.7, and this would be cubic inches. Make sure you are doing the calculator work with me so that you understand how to put it into your calculator. Okay, let's keep going. Let's try one of these cones here. So remember, same thing, volume equals area of the base times the height, all divided by 3. This time our base is a square, so we're going to use pi r squared. So our base area, or area of our base, would be pi times our radius of 2 squared, or 4 pi square inches. I'm going to leave this in terms of pi. Leave this in terms of pi until the very end of your problem. If you start rounding here, then you're going to mess up the end results, unless you round to like 4 decimal places or something like that. But it might just be easier to write the pi symbol. All right, the height goes the same way. We need this perpendicular height to the base. In this case, they gave it to us. They didn't give us a slant height. We don't have to use the Pythagorean theorem. So our height would be 8 inches. So our whole volume would be area of the base, 4 pi, times the height, all divided by 3. When you substitute that into your calculator, you should get 33.5, and this would be cubic inches. Make sure you are able to do that. I would suggest always using the pi button here, unless your problem specifically says use 3.14, that pi button is going to give you the most exact answer. Okay, pause your video, take a few moments, and try these ones. Okay, if you've worked through these ones correctly, for this first one, your volume would be pi times a radius of 4 squared times your height of 8, all divided by 3, which should then give you 134.0 cubic inches. So make sure you got that. You could also write this here as 16 pi times 8 and then divide it by 3. However you proceed through your problem is fine. For the second one, this would be a rectangular pyramid because the base is a rectangle, while our first one is a cone because our base is a circle. So this one would be area of the base, so 17.5 times 32 times the height of it. Notice this 30 is the slant height. We want this height. So the height would be 24, all divided by 3. So then our volume for this guy would be 4,480 cubic feet. Make sure you are able to get both of those. Hopefully you are by this point. Okay, let's move on to our very last shape. This is section 11.4, and we're going to talk about spheres. This is a straightforward formula. The only dimension you need to know for a sphere is the radius. Remember that radius can go out to here, it can go out to here, it can go anywhere from the center of your sphere to the edge. And then we also know the diameter then is 2 times the radius. A lot of people like to write this as 4 times pi r cubed and then divide by 3 at the end. It's the same thing as having the 4/3 out front. Whatever you prefer is fine. So let's try one of these. This time they gave us a diameter of 7, so that means our radius is 3.5. So for our volume, we would do 4 times pi times 3.5 cubed. Notice this is cubed, all over 3. So this time, I like to take care of the cubed first, just so I don't mess it up. This would be 4 times pi times, and don't round this number, keep this as exact as possible. Some of you will just put it straight into your calculator, that's fine. But 3.5 cubed is actually 42.875. Then you can put all this in your calculator and divide by 3 at the end, and you get 179.6 cubic inches. Now, just something food for thought. If we were to get a problem, and you might get one like this later, where maybe you just had this shape. So this blue shape. This blue shape would be called a hemisphere. And that hemisphere is just half of a sphere. So you can think of the volume formula for this guy to be 4 pi r cubed over 3, and then divide that whole thing by 2. Or it's the same as multiplying the 4/3 pi r cubed by 1/2. So you would end up with 4 pi r cubed over 6, or 2/3 pi r cubed. So just understand this would be your formula for a hemisphere, or you can always just take the volume of a sphere and then divide it by 2. Just some food for thought. Okay, let's try just 2 more advanced problems. You're going to have a couple like these in your homework, and then we'll be finished. So this is what we would call a composite shape. So composite means it's made up of more than one 3-dimensional shape. So right now we have a cylinder and a cone. So we always want to try to pay attention to, number 1, what shapes we have, number 2, which formulas we're going to use, and then number 3, what dimensions we're actually going to use from our diagram. So if we have a cylinder, and we learned about cylinders last time, and a cone, we're actually going to take the volume of both of those and then add them together. So our volume of a cylinder is area of the base times the height, plus the volume of the cone is area of the base times the height divided by 3. So I need to figure out what dimensions I'm actually using. Let's talk about my cylinder first. We know that the base is the circle, so that's going to be area of the base, and we know that this 5 is going to be our radius. Our height of our cylinder is how tall it is, here or here, not this 24, that's the whole shape, so we're going to use this 17 as the height. So our volume here would be area of the base, or pi times a radius of 5 squared, all times a height of 17. Plus, let's look at our cone now. Well, we know the cone has a base of a circle, so this 5 would be our radius. The height of the cone is not this 8. This 8 is the slant height. We want this actual height, so it would be this 7. So we would do area of the base, pi times 5 squared, times our height of 7, all divided by 3. So our total volume here, 5 squared is 25. This would be 25 times 17. And when you do 25 times 17, you get 425. So this would be 425 pi plus, now here we're going to do 25 times 7, and that's going to be 175. So this would be 175 pi. Whoa, my apologies. My marker's getting a little excited because we're almost finished. So this would be 175 pi all divided by 3. When you substitute those values into your calculator, carefully substitute them in, be careful of your parentheses and all of that, you should get 1,518.4. And this would be cubic centimeters. So make sure you're comfortable with that. Okay, for our last problem, we're going to take a couple of different shapes again. It says we have a cube with edges of 20 centimeters, and we're going to fill that cube with water. It's saying, would this amount of water fit into the sphere with the same 20 centimeter, but this time it's our radius? So let's think about this. If we have a cube, okay, with a 20 centimeter edge, that means that all edges are 20 centimeters. So height, and then base, and then base or height of the base. And then we have this sphere, which could be something like this, and this time we have a radius of 20. So it says, would the volume of the water in the cube fit into the sphere? So let's go ahead and find this. Volume would be area of the base times the height, or length times width times height, as some of you are used to it. So this would simply be 20 times 20 times 20, or 20 cubed, which is 8,000 cubic centimeters. So the question is, will this water fit into the sphere? Well, our sphere is 4/3 pi r cubed, or in this case, 4 times pi times 20 cubed all over 3. Now some of you are thinking, well, I know that this 20 cubed is 8,000. So if I multiply it by 4 and pi and then divide by 3, will it still be more than this 8,000 over here for our cube? Of course it will. So if we multiply this, you end up getting about 3,510.3 cubic centimeters. So your answer would be yes, the volume of the cube, or the water in the cube, would fit into the sphere. Okay, your last homework assignment is here. Oh, so proud. Some of you guys are moving on up. You're going to be juniors. Oh, sentimental moment. But here we go. So your volume worksheet here is 11.3, 11.4. So you're going to work specifically with pyramids, cones, and spheres. You will have a short quiz on this on either Wednesday or Thursday. They'll be on Pearson. Just 2 little lesson quizzes. You can use your notes. And those will be your last assignments for this whole year. So just make sure you guys are getting caught up on all your work if you're a little behind, and make sure you work on this homework. The answers will be posted before you take your quizzes. Thank you and have a productive day.